All right, here we're looking at section 9.2. And in this section, our learning targets, first we're going to draw angles in standard form, then we're going to find coterminal angles, and then thirdly we're going to use radian measure. And this is really going to help us go back and forth between degrees and radians, depending on what we're really looking at. So the first thing we have to figure out what standard position and standard form is. So in a coordinate plane, so an angle is formed, right? I fix one end of one of my rays, because remember an angle is created by two rays that share a common endpoint. So the initial side is along my x-axis. Then the other side, the terminal side, is wherever the rest of the angle is. So this is an angle that's in standard position, is where my initial side is along my x-axis, where then my terminal side can fall in any of my other quadrants. Okay, so now let's look at some examples. So first I'm supposed to draw an angle with a given measure in standard position. So let's go ahead and look at this first one. So because 240 degrees is 60 degrees more than 180, I know that my terminal angle is going to be right down here. And I always start with on my x-axis, with one ray on my x-axis. And then I can know that 240 degrees will get me to about here. And I always, when I'm drawing angles, we always go counterclockwise. So we always start at the x-axis and go counterclockwise. So now let's look at B with a measure of 500 degrees. Well, I know 500 degrees is more than one rotation because one entire rotation is a circle in 360 degrees. I can still draw that angle though. So what I do is I set my angles, my ray here still on the x-axis, and I know I have to go around once, which gives me 360 degrees, and I have to go another 140 degrees. So that's where I can draw the other side of the terminal side of that angle. So now here you see I have a negative measurement. This negative degrees tells me that I'm going to be going clockwise. It just means go the other direction. So again, I start on my x-axis and I go the other direction, so I go negative, which would be clockwise, 50 degrees. And now I can draw all of these angles on my coordinate plane. So now I want you to think about these and think about the direction you're going to be drawing them. And also I want you to imagine which quadrant they're going to end up in. Because we're going to talk some about quadrants. Now remember, when our coordinate plane, this is quadrant 1, right? Which makes sense because when I start my angle, it's the first quadrant that I pass through. So then quadrant 2, quadrant 3, and then quadrant 4. So think about which quadrant these angles will end up in. So now here's our next example. We're supposed to find one positive angle and one negative angle that are coterminal with a negative 45 degree angle. So a coterminal angle is where they share that terminal side. Remember that our first angle always starts with one ray, the initial side on my x-axis, and has a terminal side. So a coterminal angle shares that terminal side. So let's look at part A. So we can come up with any number of solutions depending on how many multiples of 360 we add, because we can go around the circle as many times as we want. So we can just look at what we're really looking at. And for these, it's often helpful to kind of draw a picture of what you're looking at. So the original angle that I get was negative 45. So here is my original angle, right, with its terminal side at a negative 45 degrees. So I know that I could add 360 degrees to that, and it would still be coterminal. Or I could subtract 360 degrees from that. Or I could add many multiples of 360 degrees. So generally when we're finding two angles that are coterminal, we generally add 360 degrees and we subtract 360 degrees to give us our two examples. So let's look at part B. Our terminal angle, our first angle was 395 degrees, and then we have to find two that go with it. So the first thing we do is draw our 395. So I know it's more than one way around the circle. So this blue line is my 395 degrees. So again, here I subtracted 360 from it, and then I subtracted 2 times 360 degrees from it. To find other angles, right, I could just add another 360 degrees to it. So you'll notice that to find coterminal angles, we're either just going to be adding or subtracting multiples of 360 degrees. That's the easiest way to find some coterminal angles. So now I want you to try this. Look to and find a positive and a negative that are coterminal with this given angle. First, draw your angle, and it doesn't have to be perfect, just kind of draw a sketch where it is, and then you can see whether you need positive angles or negative to get where you're going. So now we're looking at that third learning target. We're converting between degrees and radians. So the only difference is these are two different ways to measure the same thing. Now I like to think of degrees and radians like measuring temperature. So we can measure temperature in both Fahrenheit and Celsius, and we can convert back and forth depending on what information we need and what information we have. But it measures the same thing. Same thing with radians and degrees. We're still talking kind of an entire circle. And we always want to look at our circles on a coordinate plane, because that helps us. And we always start right here and go counterclockwise. So I know that one entire circle is 360 degrees. Okay, we've looked at that often. The other new piece of information I need to know is that one entire circle is 2 pi radians. So when we're looking at radians, we don't have a nice little symbol. So our symbol for degrees, right, is that little circle. For radians, we don't have a symbol. And oftentimes we'll write radians, but we don't always have to. So here's how I can convert back and forth. So I know that if I'm going from degrees to radians, I'm going to need radians in the top. The thing that I'm going to, that I'm converting to, is the piece that needs to be in the numerator. Okay, so I can use this pi divided by 180. I could also use 2 pi divided by 360, because I know 360 degrees is 2 pi radians. Well, this 180 and pi, because that's half of one circle, right? To get to over here is 180 degrees, but it's also pi radians, right? And I can just compare and convert different numbers and see which one I work. So this is probably the easiest ratio to use when converting back and forth. So here you'll see I'm getting 2 degrees. So my degrees has to be on the top in the numerator, and I'm still just using the same ratio of 180 degrees is pi radians. So now let's try one. So convert the degree to radians or radians to degrees. So here in A, I see I'm given degrees, so I'm going 2 radians, so my radians need to be in the top. Okay, so I multiply my 120 degrees times my radians in the top, because that's what I'm converting towards, and then I can simplify. So I know 120 divided by 180, well, they're both divisible by 10, and then they're both divisible by 6, so I can simplify. So I want to leave this as 2 pi over 3. I don't want to use my calculator to estimate, I want to leave this in exact values. So now let's look at part B. I see I've got a negative pi over 12. So since I have pi in this and I don't have the degree symbol, I know I have radians, so I need to convert to degrees. So I know that degrees is going to be in the numerator of my conversion factor. So I set up my negative pi over 12 times my conversion factor, my ratio here, and I end up with negative 180 pi over 12, and then I can just simplify my fractions. And I notice here too, I also have a pi in the numerator and a pi in the denominator, so those can cancel out as well. So a negative pi over 12 is the same thing as a negative 15 degrees. So we're really just converting back and forth between degrees and radians. So here are some for you to try. Try the different conversions. First, you want to figure out which one goes in the numerator and which one goes in the denominator, because we're really just going to be using 180 degrees and pi. Just depends on which order we want to flip them in. So now in this lesson, we're also looking at different arc lengths and different areas of sectors. Okay, so the arc length is a segment of my circumference. So I see here I have an entire circle, so I have a circumference, and I see that I have an arc length. That arc length is just a piece of the circumference. So now I'm also looking at sectors of circles. So I like to think of sectors of circles as being kind of a piece of the pie. How much of the pie am I eating? Because we want to look at the area of a circle and figure out how much of it we're looking at. Both of these hinge on what's called our central angle. So a central angle is where the vertex of that angle is at the very center of my circle. And here we're really looking at radians, okay? So make sure that your calculator is in the right mode before we actually do much of the calculations. So here's one of our just formulas that we need to know. So the arc length, which is S, we call it S, is R times theta. So it's going to be my radius times this central angle. Again, I'm in radians. The area of my sector is 1/2 r squared theta, right? Because I'm taking a piece of the circle. So that's how I can find my area of that sector. Okay, so here's kind of our problem that we're looking at. So a softball field forms a sector because it's not an entire circle, with the dimensions shown. Find the length of the outfield fence and the area of the field. Right, so the outfield fence I see would be my arc length, and the area of the field would be my sector. So I can use the information that I'm given on that last page to find what I'm looking for. The first thing I notice is I am given my angle in degrees, and in order to use the formulas on the previous page, I have to be dealing in just radians. So I want to first convert this angle measurement to radians. So since I'm going 2 radians, my pi radians is going to be in the numerator, and I can simplify and solve, and it's pi over 2 radians. So now that I have this angle in radians, I can use the other information to find my arc length and my area of my sector. So first let's find the arc length. So I know that S equals r theta. Well, I'm given an r value of 200. Theta we found was pi over 2, and I can simplify to be 100 pi, which is approximately 314. Generally, we want to leave this in exact answers unless we're finding some real world problems. Because 100 pi does not actually tell me how much fence I need to order. I need to actually kind of convert that to feet or meters. What am I actually looking at? I'm looking at feet, so I want to convert it to feet. Okay, so now we can find the area of my sector using the area formula. So I've got A equals 1/2 r squared theta. So again, my r was 200, my theta was pi over 2. It's going to end up being 10,000 pi, or approximately 31,416 feet squared. So then that's what I'm just finally answering here in this last question, is the length of the fence is about 314 feet, and the area of the field is about 31,416 square feet. And the first step I did was to convert my degrees to radians. Then I could use the formulas given on that previous page to find the arc length and the area of this sector. So now I want you to think about this question. You don't have to answer it. Just think about what information do you have and what information do you need to know. So let's look at our learning targets. First thing was drawing angles in standard form. Now standard form, remember, is where one of my sides, my initial side of the angle, is along my positive x-axis. And then I go positive angles, positive degrees go counterclockwise. Second learning target was to find coterminal angles. So coterminal angles are angles that share that terminal side. And to do this, we can just add and subtract different multiples of 360 degrees. And then our third learning target was using radian measure. So first we have to convert back and forth between degrees and radians. Then we can use radian measure to help us find arc lengths and areas of sectors of circles. So now that we've worked on these 3 learning targets, go ahead and work on your homework for 9.2.